Tiende pamoja ndi mtima umo. 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 Tiende pamoja ndi mtima umo.
Hello, good morning and welcome to MTN Teleschool. My name's By Kasonde. I'm a math teacher and I'm so pleased to be on this platform just to help you revise and prepare for your final examinations. Now today we are looking at 2016 Mathematics Paper 1. So guys, if you have comments and questions, you can simply download the MTN TV Plus application from Google Play Store and watch the lessons for free. You can as well, like our page on Facebook, MTN TV, and drop your comment. I will be able to respond to you as soon as possible. So let's quickly look at some questions from Mathematics Paper 1, 2016. And we are starting with question number 14. All right, so in this session we'll start with question number 14. So question number 14 reads, given that E, which is the universal set, is equal to A, B, C, D, E, F, G, and H, comma A, set A is A, B, C, D, and set B is B, C, D, E, F. List A union B complement. So we are given the universal set, which is A. We have the elements A, B, C, D, E, F, G, and H. Elements of set A are A, B, C, and D, and we have elements of set B as B, C, D, E, and F. All right, then the question is, we find or list elements of A union B complement. Now, showing the information we are given on a Venn diagram, let's have two sets. We have set A and we have set B. Set A and set B. Then we have the universal set, which is set E. So in the intersection set, you realize that in section A, we have A, B, C, D. That's in set A. In set B, we have B, C, D, E, F. So you can see that B, we have element B in set A, and B is also in set B. We have C in set B, which is also in set A, and we have D, which is also in set A. So A intersection B will have the elements B, C, and D. Then in set A, we are remaining with A, and in set B, we have E, F. Then when you look at the universal set, we have G and H as elements in the universal. So we have G and we have H. Now, De Morgan rule states that A union B complement is equal to A complement intersection B complement. So when we complement A and B, or the union of A and B, you realize that the entire set of A union B, all the elements in set A and in set B will actually be cancelled. Then we shall remain with two elements in the universal set, that is G and H. Therefore, we can say A union B complement, we will have G and H as our two elements of that particular set. So that is the solution for question 14, part A. All right. Then when we look at question 14, part B, we have the question: find the equation of the straight line passing through -4, 4 and is perpendicular to the straight line whose equation is y is equal to x over 7 equals 1. So this question comes from the topic called calculus. And when you look at an equation of a straight line which you are given as y, we are looking at part B, you have y plus x over 7 equals 1. So they want us to find the equation of a straight line that is passing through -4, 4. Now when you have a straight line, a line that is perpendicular to that particular, let's say we have line 1 and we have line 2. If we have the line 1, then the line 2, which is perpendicular to line y, is called the normal. And by perpendicular, I mean the two lines are intersecting at 90 degrees. All right. So how do we answer this question? I will first make y the subject. So we'll say y is equal to -x over 7 plus 1. So finding the gradient of this function, let me call it *1. You can differentiate the function y, or you use the general expression of the equation of a straight line. Now we know that equation of a straight line, the general equation of a straight line is y is equal to mx plus c. So without differentiating this function, we can simply find our gradient of equation 1. So you will notice that from equation 1, our gradient of y, which is m in this case, will have -1 over 7, because -1 over 7 is the coefficient of x. Okay? Because -7 is the coefficient of x. If you are comfortable with calculus, then what you do is you simply find the gradient or the derivative of y, which is equation 1 with respect to x, and so differentiating the term -x over 7 with respect to x, will get -1 over 7, and the derivative of a constant y is equal to 0. So using the equation of a straight line, which is the *1, and using differential calculus, we can still find our gradient as -1 over 7. Now, we need to bear in mind that we are looking for the equation of a line that is perpendicular to the equation y. All right, so we are looking for the equation of the normal. Now, what is the relationship between the gradient of a tangent or a straight line and that of a normal? So you will see that the relationship of the gradient between two perpendicular lines is that gradient of the first line multiplied by gradient of the second line will be equal to -1. So if you let gradient of y, which is gradient of the function y, m, be equal to m1, and gradient of the line that is perpendicular to the function y then be equal to m2. Then we are going to say m1 is equal to negative 1 over 7. Okay? Then we'll say m1 times m2 will give us negative 1, and therefore m2 will give us negative 1 over m1. So substituting m1 with negative 1 over 7, which is the gradient of the function y, which is equation 1, we have m2 is equal to negative 1 divided by negative 1 over 7. So this can be written as negative 1 over positive 1, then times 7 over negative 1. And so multiplying that, we'll get negative 7 over negative 1, which is the value of m2, and therefore this will give us positive 7. So in other words, we are saying that the gradient of a line that is perpendicular to the equation y plus x over 7 is equal to 1 is positive 7. So then how do we find the equation of this line that is perpendicular to the equation y plus x over 7 equal to 1? We know that the equation of a straight line, when you have gradient and you have 1 point on the line, is given by y minus y1 equals m open bracket x minus x1. So since we know that, so I'll call this as equation 2. So since we know that m2 is equal to 7, and the point that we are given, 1 point on the line, is negative 4, 4. Negative 4, 4. So I will let negative 4 be x1, and negative, I will let me just use a different color. So I will let this negative 4 be x1, and meaning positive 4 will be y1, because it is a coordinate in the y-axis. Then substituting what we have, the points in the equation 2, we get y minus the value of y1 is positive 4, so you write 4 there, equals our gradient is 7, then x, open bracket there, x, then minus the value of x1 is minus 4, so we have minus 4 close bracket. Then simplifying this equation, we will have y minus 4 equals, expanding the right side, we will have 7 times x, we have, okay, before I expand, let me just simplify what is inside the brackets. We are saying we have 7, then we'll have x plus 4. So this will give us y minus 4 is equal to 7x plus. Now when you multiply 7 by 4, you get 28. You get 28. So we have 28. Okay? Then when I transpose negative 4, I will have y is equal to 7x plus 28 plus 4. Okay? Plus 4. And the answer I will get in this case will give me y will be equal to 7x plus 32, because 28 plus 4 will give us 32. Therefore, the equation that we have here is the equation of a perpendicular line, or the equation of a straight line passing through the line whose equation is y plus x over 7 equal to 1, which is the equation of the normal. So guys, if you want to find the equation of the normal, you need to remember that a normal is a line that is perpendicular to the tangent. And by that I mean the point of intersection between the normal and the tangent is 90 degrees. So they form a 90 degrees angle. That's what it means when I say they are perpendicular to each other. And the relationship between their gradient is that the product of their gradient, which is the gradient of a normal and the gradient of a tangent, the product will give you -1. It is a very, very important point to remember. All right, so that is how we answer question number 14. So let's quickly go to question number 16. Question number 16. So question number 16, we have a question on functions. Question number 16 from Mathematics Paper 1 2016, we have a question on function. And we are given two functions in this case. The first function is f of x. Then we have 5x plus 4 over 5. And we are given that g of x is also another function, and we have x minus 1. So these are the two functions we have. Now, the first question is find f inverse of x. So question number 16 part A, find f inverse of x. So how do you find the inverse of a function? So we have the function f of x, which is equal to 5x plus 4, 5x plus 4 over 5. So the first thing that you do, you let f of x be equal to y. So we'll let f of x be equal to y. Then y will be equal to 5x plus 4 divided by 5. So when you do that, the next thing you do is make x the subject of the formula. So making x the subject of the formula, y can be written as y over 1. Then I will cross multiply. So when I cross multiply, I will have 5 times y, I will get 5y equals, then I'll have 1 multiplied by 5x plus 4. So expanding that will give me 5y equals 5x plus 4. And therefore, I can write this expression as 5x plus 4 equals 5y. And when we do that, then I will transpose positive 4 and get 5y minus 4. So transposing positive 4 is as good as adding both sides by the additive inverse of positive 4. So the additive inverse of positive 4 is negative 4. Why? Because we want to add 4 to its additive inverse in order to get 0, which is called the additive inverse in this case. So we have 5x is equal to 5y equals 4. Then I will multiply, because my focus here is to make x the subject of the formula. So I will multiply both sides by the multiplicative inverse of positive 5, which is as good as dividing both sides by 5. So when I divide both sides by positive 5, I'll have 1 in 5 into 5, I'll have 1, and 5 into 5, 1. So I'll get x is equal to 5y minus 4 over 5. Then, since I have made x the subject, then I will now change x. In this case will now be, if I let now x be equal to f inverse of x, then I will have f inverse of x, and then wherever there is y, I will put x. So I will change The y in this case will become x minus 4 over 5. So what we are saying is that you are replacing this x will now become f inverse of x, and the y which is this y will now be changed to x when writing your final expression. And so that is what we are going to have. So therefore we are saying that our final answer in this case will now be the inverse of f, which is f inverse of x, will be 5x minus 4 divided by 5 as our final answer for part A. So that is how you find the inverse of that matrix, that function. Now, in case you just tuned in, you are watching MTN Teleschool. Okay, so if you have questions or comments, you can simply go on Facebook, like our page MTN Zambia, and ask your questions. I will be able to respond to you in time. You can as well download the MTN TV Plus application from Google Play Store. Guys, you need to take note that this is my last presentation for this year, so make sure that you watch the show and comment so that I interact with you even outside this platform. All right, so we are still answering question number 16, and we are on question number 16. We just finished looking at part A. Now let's look at part B. Part B, we are asked to find f inverse of negative 2. So we already found that f inverse of x, the function f inverse of x, is given by 5x minus 4 over y. So we know that inverse of x, okay, is given by 5x minus 4 over 5. That is the inverse of the function of f of x. Then at x is equal to minus 2, f inverse of x. So in this equation, which is equation 1, wherever there is x, I will put negative 2. So when I substitute this x by a negative 2, it means that even on the right hand side, wherever there is x, I will put minus 2. So we have minus 2 equals 5. So I will substitute this x with negative 2. Then we have minus 4 over 5. All right. Then simplifying the right hand side, we will have 5 multiplied by minus 2. We will have minus 10. Then minus 4 over 5. So minus 10 minus 4, we will have minus 14 over 5. Minus 14 over 5, and that is the value of f inverse of negative 2. So therefore, f inverse of minus 2 will be given by, will now be equal to 14, negative 14 over 5 as our solution. So that is how you answer question part B for question 16 under function, which is inverse function. So we quickly go to part C of question 16, which is a composite function. So we have f g of x, that is part C of a composite function. So what does this mean? Fg of x. Fg of x is a composite function, and by implication, when I write fg of x, I'm saying f of g of x. So g of x will first of all become the image of the function f. So f g of x will also be written as f g of x. So since we have our function f of x, our function f of x is equal to 5x plus 4 over 5. Now, if you have f g of x, we also know that g of x is the function x minus 1. So, it means that f g of x, it means that in this case, the function g of x is acting as an object. Okay? So, f will act on g of x. That's what it means. So, g of x will now become the object of g of x. But g of x, we already know that g of x is the function x minus 1. So, if we have f of x minus 1, we already know that f of x is 5x plus 4 over 5. So, the function g becomes an object. By implication, we are saying that in the function f of x, wherever there is x, we need to replace by the function g of x, which is x minus 1. So, we are going to have 5, and where there is x, we'll substitute by x minus 1, then plus 4 divided by 5. So, simplifying the right hand side here, we are going to expand by distributing 5. So, we'll have 5 multiplied by x, we'll have 5x. Then 5 multiplied by negative 1, we'll have minus 5, then plus 4 divided by 5. So, reducing this, we'll have 5x, then minus 5 and positive 4 are constants, so minus 5 plus 4 will get minus 1 divided by 5. Therefore, the composite function f round g or f of g of x will give us will give us 5 minus 1 over 5 as the final solution, as our final solution. Alright guys, so that is how you answer question number 16. So we have another question that we are going to look at just after this break. So for now, let's take a quick break. I will be back in 2 minutes. Stay tuned.
I told the bus driver that I work hard for my money, so it better gets to Chipata.
Yeah, that's right. That's what I told him.
Yeah.
Weather, drama no, or Zambili.
Tituma. And he kept trying to tell us something, but I was like, Ukagamba, Tilo.
Cause cash money yave across Zambia.
Tituma. At Basi and Kuchpat. The end of South Africa. Hello, what?
Run, K-Star, run! You got the bus.
Sending money doesn't have to be this dramatic. Open an MTN mobile money account today and send money to friends and loved ones across Zambia instantly. Dial *303# to send money with MTN, Zambia's #1 network. With MTN mobile money, Tituma.
MTN, everywhere you go.
Hello! This is all you need to know about data bundles. Like when you need airtime to make calls, you need data bundles to browse the internet, send and receive photos on Facebook, chat on WhatsApp, send emails, listen to music, and many other things. Data is measured in bytes, kilobytes, megabytes, and gigabytes. These are a bit like money, and just like your bank balance, your MTN account has a data balance that you can use to buy data bundles ranging from 5 megabytes to 20 gigabytes for daily, weekly, and monthly subscription. To buy a bundle, dial *335*1#.
From sending emails to browsing or watching online videos, many of the things you use depend on your device's functionality and network capability. Entry-level devices have limited data usage, whereas smartphones and computers have limitless data usage. The longer you spend online, the more data you use.
Sometimes you feel like your data is running out really fast. That's because today's modern technology and higher definition content require and use up a lot more data. No need to worry. Data can be managed to work for you by minimizing on the number of apps that automatically update themselves and turning off your data when not in use. Make sure you use data bundles to browse the internet. When your bundle is depleted, you will be billed from your airtime. Perform regular data balance inquiries by dialing *335*3#.
Alright, welcome back guys. You're watching MTN Teleschool with me, By Kasonde from Kafio Boys Secondary School. And thank you so much guys for tuning in. I can see Crystal Piri, you are watching. Thank you so much for tuning in. We really appreciate Serena Nyangwe. Thank you for showing us the love. We really appreciate Leah Piri. Kalua Chang, I can see you are watching from Mazaboka. Yeah, how is Mazaboka? Mulivuti, thank you so much for tuning in. We have Mavis Prime. Thank you so much for tuning in. I can see you're watching. Thank you guys. So stay tuned guys and tag your friends. Christopher Mwanza, I can see you're also watching. Kennedy Chileshe, Maya Mulenga, thank you so much guys. Thank you so much guys. We really appreciate. So stay tuned and tag your friends. By the way, this is my last presentation for this year, so make sure you comment and ask your questions so that we can interact even outside this platform guys. I really want to just be there and help you also prepare for your final examination. Thank you so much guys for tuning in. So let's go back to our paper, which is 2016 Mathematics Paper 1, and look at question number 18. All right, so our question number 18, we have two parts. There is part A and part B. So part A of the question is, find the integral of 6x squared minus 5 dx. All right. So question 18 part A, we have the integral of 6x squared minus 5 dx. And so when I write dx, by implication I'm saying that the function 6x squared was differentiated with respect to x. Now we are trying to take it back to its original function. That's what it is all about. So integration is simply antiderivative, or the reverse of differentiation. So when you are given a function 6x squared minus 5 dx, we simply say, or by implication we are saying that there was a function that was differentiated with respect to x. Now our task is to take it back to the original function. Now when we look at the integral sign, we do not have limits. And so this kind of an integral is called an indefinite integral. So when we are dealing with indefinite integrals, we'll always have the constant of integration, which is c. So how do we integrate? Yesterday I talked about basics of integration, but then I'll remind you that when you are given a function, or let's say the question is, we want you to integrate the function ax raised to the power n dx. Then what you do is that the integral will be a divided by the power plus 1, which is n plus 1. Then you have your variable x. Then the power will be added by 1, and you will add the entire function or the entire term by a constant c, which is called the constant of integration. So getting back to our question, our function is 6x squared minus 5, which is the integral of 6x squared minus 5. Then we have dx. So it simply means that each term will be integrated with respect to x. So when you look at the integral of 6x squared is a term on its own. So this will be equal to the integral of 6x squared dx, then minus the integral of 5 dx. So when you do that, then we will integrate x 6x squared raised to the power 2, and using this rule or using the procedure we have here, we can say the integral of 6x squared will give us 6 divided by the power of x is 2, we add by 1, then we have x, the power of x will add this power of x by 1, which is 2 plus 1, then we have minus, then we know that under indices, okay, we have a minus sign there. Now we know that under indices, when I write x raised to the power 0, this gives me 1. So what I'm going to do is that for this integral, we'll have x, I'll introduce this arbitrary x, but then we know that this x is a 1, okay? This x is a 1 because any number raised to the power 0 gives you 1. So we have the x. Now, I will use the same method. So we'll have 6 over 3 plus multiplied by x raised to the power 3 minus. Now, integrating the function 5x raised to the power 0, I will say 5 over the power is 0 plus 1, then x the power is 0 plus 1, then plus the constant of integration. So simplifying that, we'll get 3 into 6, we have 2x cubed, then minus 0 plus 1 will get 1, 1 into 5 will get 5, so we'll have 5, then x, the index there which is 0 plus 1 will get 1, but then we can just leave it as x, then plus the constant of integration. So you can verify that indeed this is the answer that we are looking for, because when you have, let me just use the first term which is 2x, let's say you have 2x cubed, then it means that the derivative of qx, which is the derivative of 2x raised to the power 3 with respect to x, will give me, we know that when you are differentiating a function which is ax raised to the power n, it means that you multiply the coefficient of x which is a by n, then subtract the power of x by 1. So when I do that, you realize that when I multiply 3 by 2, I will get 6, then x, the power of x will be subtracted by 1, which will give me 2. I will have 6x squared, which takes us back to the term that we have here, which is 6x squared. So that's what it means. By implication, we are saying that there is a function that was differentiated, and then that function that was differentiated will now need to be taken back to the original function, which is what we have here. I'm calling it as a star 1. But then we need to realize that when you differentiate a constant, then your derivative will be 0. That is why we introduce a constant of integration to show that there was a constant that was being differentiated, but then we don't know what this constant is. That's why we just put letter C to show that there was a constant of differentiation or integration there. All right guys, so that is how you answer that question. The final answer here is 2x raised to the power 3 minus 5x plus C as the final answer, which is the integral of the function that we are given. So that is what we needed to do on question 18, part A. All right, so for part B of question 18, we have the question. This question is from the topic called trigonometry. And if we look at the question, the triangle that we are given is a non-right angled triangle. So, the question says the diagram below shows triangle PQR in which PQ is 12 centimeters, QR is 10 centimeters, and the angle PQR is 150. The question is calculate the area of triangle PQR. So that's what we need to do. They are asking us to calculate the area of triangle PQR. So how do you calculate the area of non-right angled triangle in this case? When you are given angles and two sides, there is one known angle and two known sides. So the area will be given by, let's say one known side is A, another known side is B. Then we'll have sine of a known angle, then divide everything by 2. So when you look at our diagram, we have a triangle that looks like that. We have 120 degrees, and this is P, which is the vertex there. Then we have Q and R. This is 10 centimeters, and that is 12 centimeters. So we have two known sides. Now, because this is capital P, let me call the side PR, which is 10 centimeters, as small letter p. So I'll use small letter p to denote. And the line PQ is opposite. Okay, let me write this. And 50 degrees here. This is 150 degrees. Yes, we have 150 degrees, so we made a mistake on that one. The question says we have 150 degrees, not 120. All right, so the line PQ will be denoted by small letter r because it is the vertex that is opposite to the line PQ. So when we have that now, we can now substitute what we have. So by implication, we are saying that we are going to have A is equal to PR, then sine, because the angle Q there is 150, so we'll have Q then divided by 2. So when I substitute the distances, we'll have P, which is 10 centimeters, 10 centimeters. Then the distance R, we'll have 12 centimeters. Then multiplied by sine of 150 degrees. Then we divide everything by 2. So then this will give us, when you multiply 10 by 12, you get 120 square centimeters. Then we are multiplying this by sine 150. So you can use special angles to find the value of sine 150, but when you calculate, you would find that the value of 120 multiplied by sine 150 will get 60 square centimeter equals, divided by 2. And so when you divide 60 square centimeters by 2, you get 30 square centimeters. Therefore, the area of this triangle will give us 30 square centimeters. So that is how you answer this question on trigonometry. All right, that is how we answer this question on trigonometry. Okay, so let's quickly answer question 20. We quickly go to question 20. All right, so thank you so much, guys. I can see some comments on our Facebook page. Anthony Mwenya, you are watching. Thank you so much for tuning in. PF Kuyabevele. Well, all right, thank you for that comment. We really appreciate it, and thanks for tuning in. We really appreciate. Okay, so we get back to our lesson and answer question number 20. Question number 20. All right, so question number 20. This question is on variation. So we are given a question, and the question is, it is given that W varies directly as the square of X and inversely as Y. So writing that, or translating the statement into a mathematical statement, we'll have W varies, so that is the symbol of variation, varies directly as the square of x, which is x squared, and inversely as y. So we are dividing by 1 because the inverse of y is y over 1, or 1 over y as a multiplicative inverse. So that is what we are doing. We are using and, implying that we are multiplying there. So there is a multiplicative inverse of y, which is 1 over y. So we can write this as W varies directly as x squared, or the square of x, and inversely as y. Now, the first question, which is part A of question 20, the question is write an expression for W in terms of x, y, and a constant of variation, which is k. So, when you introduce a constant of variation, the symbol or the operation of variation there will change. So we'll write W. When I put an equal sign there, I'll introduce a constant of variation on the right hand side of the equation and multiply a constant of variation by the term on the right hand side, which is x squared over y. That is the expression in terms of x, y, and k. So we have done part A of question 20. That is how you write it. Then part B, if x is equal to minus 6, so we write minus 6. So the part B, we have been given some parameters there, or some values of x, y, and w, those that we can use to find the value of k. So x is equal to negative 6, y is equal to 12, and w is equal to 15. So they are asking us to find k. Now from the result we got in part A, we have w is equal to kx squared over y. So our w is 15. K, we don't know what that is. It's what we are solving for. Then the value of x is negative 6 squared, then divided by the value of y is 12. So we'll have 15 equals k. Now negative 6 multiplied by negative 6, which is the square of negative 6, will get positive 36, then divided by 12. So we are saying that 15 will be equal to 36k, then divided by 12. So we can simplify the right hand side because we know that 12 can go into 36. So 12 into 36 will get 3. So we'll have 3k. Therefore our equation can also be written as 3k is equal to 15. So multiplying both sides by the multiplicative inverse of k, we are going to have 3k divided by 3 is equal to 15 divided by 3, which will give us k is equal to 3 into 15, we get 5. And therefore, the value of k in this case is positive 5. All right, so that is how you answer that question. All right, so Bibiana Guava Ichigo, thank you so much for tuning in. I can actually see your comment. Mwaya Mulenga, thank you so much. I will do that. I've seen your comment. I will indeed inbox you my number so that you ask your questions. Thank you so much. Jaliso Henry, thank you so much for tuning in. We are pleased that you are watching us. Thank you so much. And please remember to tag your friends so that we can actually push through this work together. Thank you so much, guys. All right, so we go to part C of question number 20. Part C of question number 20. Find the value of y when x is equal to 8 and w is equal to 20. All right. So we've been given the value of x as positive 8, the value of w as positive 20. All right. Now, we have our general expression in terms of k as kx squared over y. We have kx squared over y, but we just found our value of k as 5. We know that k is equal to 5. So our general expression will be 5x squared over y. So let me call this as tower now in this case. So we have been given the value of w as 20, so we'll substitute 20 into star 1. Then 5, where there is x, we'll put 8 squared, then divided by y. We are looking for y. So I will cross multiply, and so I will have 20y will be equal to 5. 8 squared, that is 8 times 8, it will give us 64. And so when I multiply 5 by 64, I will get 320. Okay, I will get 320. And so finding the value of y, I will divide both sides by the coefficient of y, which is 20. So I will have 20y will be equal to, all right, so 20y over 20 then equals to 320 divided by 20. So that will go, because 20 into 20 will get 1, 20 into 20 will get 1, then 1 into 1 it's 1, then 1 multiplied by y will simply get y. So we can simplify the right hand side there. So this 0 and that's 0. How many times can 2 go into 32? We'll see that 2 can go 16 times into 32, and therefore the value of y is 16. So that is how you answer that question under variation, and that is question number 20. All right, so let's go to question number 21, which is the last question for today, guys. Like I said, this is my last presentation for this year on this platform. So make sure that you drop your questions and your comments. I will be able to respond to them even outside this platform. We will be pleased to actually hear from you and just keep on interacting with you until the time you write your final examinations. Please don't forget to tag your friends. Make sure you tag your friends, and remember to download our application from Google Play Store, that is MTN TV Plus. You will be able to watch all the lessons free of charge. All right, thank you so much, guys. So let's look at our last question, which is question number 21. All right, so question number 21 is a question on linear programming. Okay, we have a question on linear programming. Okay, so this question, they want us to find the inequalities. Okay, and when you look at linear programming, these inequalities are also called constraints. Okay, so the task that we have here today is just simply to actually find the equations of these constraints. Okay, the equation of the constraints in order for us to define the region R. Okay, so when you look at that question, we have been given a diagram. Okay, and on that diagram we have a graph where we have the x or y plane, which is the Cartesian plane, and we have some constraints on this Cartesian plane. Now, this Cartesian plane, when you look at it critically, you see that maybe, let me just try to sketch this Cartesian plane so that we understand exactly what I'm talking about. So we have the y-axis and we have our x-axis like that. So we can say we have values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then in the y-axis, we have values 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 2, 3, 4, 5, 6, 7, 8, and question 9, then we have the origin. So the first constraint, when you look at the question, you will see that, let me use different colors. You will see that the first line is passing here, going upwards, like that. Not at that point. It's passing at 2, which is 2, going upwards, like that. All right. Then this line is shaded on this side. Then we have another constraint there. It is passing at point 3, going into this direction, and this is shaded down here. Don't worry about my sketch. These are straight lines I'm drawing. Okay. Then we have another line, straight line, which is passing just at 7 in the y-axis, going like that, and it is shaded up here like that. Then we have a dotted line, which is another constraint, which is intersecting the line which is passing at 7 there at 5,7. So at 5,7 somewhere there, we have the point there. Then it is also intersecting with the other line there at 9, then we are looking for, it's here, this is the region we are looking for. All right, so now let's quickly find the inequalities, which are these constraints we are talking about now that we have a sketch. So you can see that the first inequality, which is number 1 there, the first inequality, let's start with this blue one here. You will see that the line is bored and it is passing exactly at 2. So when the line is passing at 2, you will see that this line that is passing at 2, you have x, it's in the x-axis. Actually, the line is perpendicular to the x-axis. It is cutting the x-axis at 2. So we'll have x, and then you write your 2 like that. Now, when you look at the shaded part, this shaded part is the unwanted region, because the wanted region is R, this one denoted by R. Now, when you look at the shaded part is the unwanted region, meaning solutions are on the right side of 2. So those values that are on the right side of 2, you will see that those are greater than 2. But since the line is bored, then we use the inequality symbol greater or equal to. So you will see that going this side in the x-axis, we are looking for the values that are greater or equal to 2. So 2 is part of the solution, and we can see that the line is bored. So that is our first constraint. Then number 2, it is our first constraint, or you can also call it the inequality, it's fine. But under linear programming, we are calling it as a constraint. Okay. So when you look at number 2, let's look at the line that is passing at point 3 in the y-axis. So when you look at that line, you have y because it is cutting the y-axis, and you have point 3. But when you look at the wanted region, it is on the upper part of the line. So it implies that we are looking for values that are above 3, meaning starting from 3 going upwards. So it means that y will also be greater or equal to 3, because we are dealing with a bored line. Then you can also look at another inequality, which is also in the y-axis. This line is passing at point number 7. We have y and we have 7, which is positive. But when you look at the unwanted region, which is the shaded part, is above the line. So we are looking for the values that are starting from 7 and coming down in the y-axis. So the values of y are less or equal to 7. And I'm using less or equal to because the lines are bold, which implies that the solutions at that same particular point is also included. Then we look at our constraint number 4. Now, when you look at this constraint number 4, so let me label the lines as line 1. We have this as line 1. Then I use that as line 2. Then line 3. Then we have L4, which is the inequality number 4. That is what we are looking for. So we are looking at the line there, okay, which is a line. When you look at that line, which is line number 4, this will give us the equation into two variables. So what we are going to do is that we'll first of all need to find the equation of the line. Now, according to the question, this line is a dotted line. So I will just make a dotted line which will pass at that particular point. When you look at the question, you see that this line is a dotted line, and by implication it means that the solutions on the line are not included. So I will pick 2 points from the line. In this case, I will pick the point 5, 7. That is the point number 1 I will pick on the line. These points are on the line, so I will pick 5, 7. And let me also pick the point 9, 3. So we can use the 2 points to find the gradient of a straight line and then find the equation of that particular line. So finding gradient, we are told that it is change in y over change in x, So here we need to actually give these two coordinates some subscript. So if we let this as x1, then this will be y1, and the other point will be x2, and this will be y2. So we have 5, 7 as point number 1, implying that the coordinates will have x as x1, y1, the coordinate of y on that point, and then on the next point, which is point number 2, we'll have 9, which is the x coordinate, as x2. So substituting the value into the equation, we'll have m equal to, the value of y will be 3, then minus, that is y2, then minus y1, which is 7, divided by, we have x2, which is 9, minus positive 5. So when you get that 3 minus 7, you get minus 4, and the 9 minus 5, you get positive 4, which gives us negative 1. Therefore, our gradient is equal to negative 1. Now, we can pick any of the points between point number 1 or point number 2 and use it to find the equation of the line. So you will see that when I pick one point, let's say I use point number 1, which is 5. We are saying that we are at 5. We are at 5,7. 5,7. So we use the equation y minus y1, which is equals to m x minus x1. Then we'll have y minus, this will become x1, this will be y1. So where there is y1, I'll put positive 7 minus, then our gradient is negative 1, we have x, then the value of x1 is minus 5. So simplifying that, we'll get y minus 7 minus x plus 5. Then we get y will be equal to minus x plus 5 plus 7, which will give us y is equal to minus x plus 12. So this is the equation of that straight line, which is the equation of this straight line. Okay, straight line, line number 4. So here now, we need to test the values. Now, how do we test the values? In order for you to know the inequality of this, you pick any coordinate or any point that is above or below the line. Now we can see that the wanted region is below the line. So I will pick any point that is below the given line. So when I pick 5,5, 5,5 will be a point that will still be below the line. It will be somewhere there. So when I pick 5,5, you see that at 5,5, we are going to have, when I substitute, this is the coordinate of x, this is the coordinate of y. When I substitute in this equation, star, I'll have 5 equals minus 5 plus 12, which will give me 5 equals, then minus 5 plus 12, that will give me positive 7. Now, you can see that 5 is not equal to 7. So what inequality symbol am I going to use in order for me to have a meaningful mathematical expression? So you will see that the meaningful inequality sign I will have there is that 5 has to be less than 7. And I will not use less or equal to because we have a dotted line there. So since 5 is less than 7 at 5,5, then it simply means that the inequality number 4 will be y is less than minus x plus 12. And that is your inequality number 4. So that is how you get the inequalities when you are dealing with linear programming. All right, guys. So we now come to the end of this lesson. Thank you so much, guys, for staying with me. Your presenter once again, By Kasonde, and it's really a pleasure being on this platform just to help you revise and just prepare adequately for your final examination. Guys, I'll see you obviously next year. I'll see you with more questions on this platform. For now, I'll say goodbye and stay yellow.
I told the bus driver that I work hard for my money, so it better gets to Chipata.
Yeah, that's right. That's what I told him.
Yeah.
Weather, drama is no, or Zambili.
Tituma. And he kept trying to tell us something, but I was like, Ukagamba, Tiloa.
Cause cash money yave across Zambia.
Tituma. At bus and Kuchpat. The end of South Africa. Hello, what?
Run, K-Star, run! Don't cut the bus.
Sending money doesn't have to be this dramatic. Open an MTN mobile money account today and send money to friends and loved ones across Zambia instantly. Dial *303# to send money with MTN, Zambia's #1 network. With MTN mobile money, Tituma.
MTN. Everywhere you go.
I told the bus driver that I work.
Tiende pamoja ni mtima umo. 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 Tiende pamoja ni